a few of these. My y-intercept's -2, and then I'm graphing this line in black, so I'm going to go down 1/1, draw a careful, we'll draw a line hopefully. Alright, then I'm going to go to the line y equals 4, we'll do that in red. Let's go ahead and find out where those intersect. So I'm going to say -x minus 2 equals 4, -x equals 6, x equals -6. However, I might need the y point in a minute, so this point is -6, 4, because you know it intercepts 4. And the line, we'll do this one in blue, x equals -1. Alright, so we have this region right here, and then they tell us to revolve around the line x equals -1. X equals -1 is like the y-axis. So since it's vertical like the y-axis, we're going to do it in terms of y. So I'm going to go pi integral. It's not going to be washers. So I have pi r squared dy. My y's, oh, I need to find where it intersects down here also. Right, so I need to know where this line intersects -1. So I have -x minus 2 equals -1. So I get -x equals 1, x equals -1. And of course we knew that. So we need to fill in -1 to get our y point for x. So that was sort of a waste of time. We know x is -1. And when x is -1, this point would be -1 minus 2. So it's going to be -1, -1. So my y values are going to go from -1 to 4. -1 to 4. And since I'm doing it in terms of y, I'm going to do right minus left, right minus left, right minus left, right minus left. So whatever's on the right now is -1, minus left, which I've got to solve this for x. So this is y is equal to -x minus 2. So I get y plus 2. Let's move our x over. I move my x over. X is equal to -y minus 2. And so they asked me just to set it up, but do not evaluate. So that was kind of messy. But there's our setup right there. And so if you look at the answer sheet, it's okay if you do it backwards because you're squaring it, but we're going to end up with the exact same thing if you do it the way that I set it up, which I recommend. Just sticking with right minus left, right minus left. Let's go to set up. Now here we were again revolving around a line like the y-axis. All right, let's drop down. I want to make sure I get some other types. Let's try number 5. All right, in the first quadrant you have sine x. So this goes up 1, and this is pi. This is pi over 2. And I might need to draw more of it, but we'll see. So in the first quadrant, and then you have, so that means you're just not going to look back here at any of the sine graphs. You've got this sine graph going. Y equals 0, which is the x-axis, so we'll make that blue. And the line x equals pi over 2. All right, so you have this region right here. And where are we going? We are going around the line x equals pi over 2, which is straight up and down like the y-axis. So it's straight up and down like the y-axis. So we're taking this, and we're going to revolve it around that way. So it says the y-axis, I'm going to be right minus left. So I'm going to take the integral, pi. I still don't have washers, so I just have one thing squared. But I just need to find the length of this, but it will not be washers. So you have one thing squared, but the one thing squared is the line minus the curve. So I have the line minus the curve, the line minus the curve, and it's right up against what it's revolving around. So my line is -1, minus the curve, which is sine x. And I'm going to go from, make sure you do it with the y's. You're taking your y's from 0 to 1. Once you think through these, you'll get a lot better at them. Oh, I'm sorry. This is, I forgot to solve this one. So let's undo that. I've got to do it in terms of y. You don't want an x and a y in there. All right, so this equation, I needed to solve for x like this equation was solved for x. So once you're doing something like the y-axis, you need to solve them all for x in terms of y. So down here, I have y is equal to sine x. So x is equal to arc sine y. And they didn't tell us to, oh, and here I needed to say pi over 2 minus. I just messed that up completely. We'll do that again. You may have caught my mistake, but it's worth undoing and doing it again. All right, so to be clear, I've got to do this in terms of y because they're telling me to revolve it around pi over 2. And so here, I am going to go right minus left. That was correct. So right in this region, I'm going to go right minus left. And this was the line pi over 2. So I'm going to say pi over 2, and because that's what x equals, and then I need to know what this x equals. And x equals inverse sine of y. So I'll write inverse sine of y. And then I've got to make sure my limits of integration are crawling up this way, because we're going up and down, so that would go from 0 to 1. All right, so that is your setup for that one. Let's do number 7. All right, so we have y equals x squared minus 3. Are all of these set up but do not evaluate? Okay. Hopefully you could evaluate them. So you have x squared minus 3. They come like this. All right, and y equals negative 2. I think I maybe did this one in class. And revolve around the line y equals negative 2. So this is also not washers. So I'm going to say pi integral of something squared. Now we're revolving along the line that we are right up next to, y equals negative 2, which is like the x-axis, so this is going to be in terms of x. I think I showed you in class today I can use symmetry to my advantage and double this and just go from 0 to this intersecting point right here, which we'll find in just a minute. And when you're doing it in terms of x, you do top minus bottom. Top minus bottom, top minus bottom, top minus bottom squared. So, because you're revolving right around that axis. So you have red, which is negative 2, minus this line, which is black, which is x squared minus 3. Make sure you put that in parentheses. I need to know where x squared minus 3 intersects negative 2. So you get x squared equals 1. And so this would be 1. This one over here would be negative 1, but since I'm only taking half of it and doubling it, I'm going to call that 1 for my setup. And that's what you would get if you check your, you would get the same answer. On the answer sheet, they didn't use symmetry, but it's still the same thing. Let's do 8. You might want to turn the video off and try it by yourself right now then. All right, x equals negative y squared is going to look like this. You might need to think about that some more. Let's get some units of measure. If you put in a y of 1, you'll get x is negative 1. So you have negative 1, 1. You've got to remember to go that way. Same thing if you put in negative 1. So you've got these two dots. All right, x equals negative 4. So it's way back here. Sorry, it's running into this. X equals negative 4 will be red. and you're revolving around that exact line. So you're going along here, and this is like in yellow for a minute, then I'll turn it red again, like right, well, you can't really see that, and black. Oh, there's the yellow. Make it blue, and blue, that's like the y-axis. So I'm going to do it in terms of y. I'm going to use symmetry. I'm going to do this part and double it. So I'm going to do this part and double it. So I am going from here, you're going to be going right minus left, and squaring it. So here you have curve, which is negative y squared, minus negative 4, so it'll be plus 4. And let's see, we want to crawl up the y-axis, like we're coming up like this way. You can't really see what I just did there, just a minute. Okay, so I had this. I want this part. So I'm doing it perpendicular to the axis I'm revolving around. So I'm climbing up like this. 1, 2, just going up like this. So like I said, that's going to be negative y squared minus negative 4 pi r squared. And I'm going to go from 0 to wherever these meet. So I'm going to say, where does negative y squared meet negative? Be careful, because this is an x equals, and so is this. So I can just set those equal to each other, but be careful. So where y squared equals 4, so this one would happen at 2. This one would happen at negative 2, but I'm going to double it and go from 0 to 2. And you can see the same thing on the answer sheet. They have theirs backwards from ours. On the answer sheet it says y squared minus 4. But if you look at the difference in negative y squared plus 4 squared and y squared minus 4 squared, you're going to get the exact same answer if you think about doing that FOIL. It's sort of like these are complete opposites. And if you take complete opposites and square them, you get the same thing. And I'm used to grading, so I want to keep y'all with right minus left. Right minus left. Right minus left. Since you're squaring it, you're going to be fine.